Hello, Algebra 2. So, we have already talked about Chapter 4, Section 1 in class, where we graphed quadratic functions. Now we are going to be solving quadratic equations. The difference, a function we know is a graph, right? It's usually starts f of x equals. Since it's quadratic, in this case, it's going to have the form ax squared plus bx plus c. We know the b or the c or the c, they could be 0. Potentially, we could just have x squared, but a cannot be 0. It could be 1, so I could have something as simple as just x squared, or I could have something more complicated than that. Now, graphing that function is well and good, but we can use that graph to solve the resulting equations. So, a quadratic equation is going to have a very similar form. Notice right here. The key to this is it has to be equal to 0. That has to be the case. If I gave you something, for example, like, let's do something simple, like x squared equals 9. That is not in the proper quadratic equation that we need right now. I need it to be set equal to 0. So how do I fix that? I'm just going to subtract that 9 off to the other side. I now have x squared minus 9 equals 0. Life is good now. It's set equal to 0. What we're going to do to solve these quadratic equations by graphing is, once it's set equal to 0, we're going to graph the other side of the equation. So in this case, I would graph f of x equals x squared minus 9 and see what happens from there. So have it set equal to 0 and then graph the resulting equation, the other side that is not 0. Now when we graph it, what we look for, we're going to call these there's a lot of different names we might say, so you'll hear me switch between them, you'll see them on this paper different ways. We can call them the roots of a quadratic equation. We could also call them the solutions to the quadratic equation, or, especially if we're talking about the graph, these are the zeros of the quadratic equation. Also, if we call them zeros, we've actually used that word before. That's not unique to quadratic equations. If ever we have a function and we're graphing it, the zeros are the x-intercepts, which is written in this statement here. So the zeros, the x-intercepts, the solutions, the roots, they all mean the same thing. It's get your equation, set it equal to 0, the x values that are given by these answers, when you plug it in, it will give you 0. That's all it says. So what we're going to do is graph these and then look to the x-intercepts. So in this case, it's already graphed for us. I see that my x-intercepts are right here. So that x value is 2. And right here, that x value is negative 3. So my zeros for this equation here, the equation that's written right here, already set equal to 0. The solutions, the zeros, the roots, the solutions, whatever you want to call those there, are negative 3 and 2. For most of these, you are going to see 2 solutions. You could also see 1 solution. You could also see no solutions, but you'll never see more than 2. So 2, 1, or none, but there are never more than 2. So let's try one of these. First thing we're going to do is just graph it up, and it's like what we did in section 1. First thing I want to do is be smart about my graph, and I want to find the vertex first. The vertex tells me where the middle of the graph is. It also tells me if that's like the low or the high spot. So I see from here that I know my vertex is going to be the minimum value, because my a value is 1. I see that right here. And that is greater than, not 0. Well, yeah, greater than 0. It's positive. That's the important part. So I know it's going to be a U shape like that type of a parabola shape. So where the vertex is, the x-coordinate is negative b over 2a, negative 2 over 2 times 1. So I have negative 1 as my x value. My y value then, I'm going to graph the resulting equation. So really, I don't need this equals 0 anymore. I could just say this is f of x. Now, so f of x equals, 1x squared plus 2x minus 8. So my x coordinate of the vertex is -1. My y value is going to be 1 times x squared, but my x is -1, plus 2 times -1 minus 8. So I have 1 times 1 is 1, minus 2 minus 8, so I have -1 minus 8, so I have minus 9. So my vertex is at -1, -9. From there, I'm going to graph some more points. I'm going to give myself an x, y table here. I know that -1 is in the middle. And what I'm going to do, I'm going to graph 5 points to start, but you want to make sure that you graph enough that your graph crosses the x-axis. These 5 that I pick might not be wide enough to make that happen, so we'll see. You'll see how that goes. Here we go. So -1, I know -9 is what's going on there. I'm also going to test 0 and +1, mainly because those are the easy ones. Then we know that the parabola is symmetric, so once I know 0, I will also know -2. And once I know 1, I will also know -3, since they are symmetric over the vertex there, over the axis of symmetry. So if I plug in 0, I'm just going to get -8. We also know that this is the y-intercept. So that's good to know. If I plug in 1, I'm going to get 1 plus 2 minus 8. So I get -5. So notice I haven't quite gotten as high as the x-axis yet. So I'm going to have to go a little bit farther. So let me do that. If I plug in 2, what happens? Let's see. I'm going to get 4 plus 4 minus 8. Oh, look. How fun. I got 0. That's what I wanted. I wanted this equation to equal 0. So I'm going to do one more just to see if I can fit that on my graph. If I do 3, I'm going to have 9 plus 6 minus 8. So that's going to be off my graph, it looks like. I'm going to get a 7 there. But you see how it's super negative to start, and then it gets more and more positive because we know the graph is doing this. Let's graph these points. At -1, I have -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex. I know the parabola is going to be going like this, again, because my a value is positive. Then at 1, I am at... Sorry, at 0, I'm at -8. At 1, I'm at -5. 1, 2, 3, 4, 5. At 2, I am at 0. And at 3, I'm at 7, which is off my graph. Now, I know that I am symmetric, like I've said, over this axis of symmetry here. So I'm going to reflect all these points. This is one box over, so I'm going to go one box over this way. This is 2, so I'm going to go over 2. This is 3, so I'm going to go over 3. And there's my other 0. Take a look at that. So, here we go. I have my parabola drawn up there. Again, the solutions, the roots, the zeros, the x-intercepts, they're all the same thing, and they are, like I said, the x-intercepts. I see them right here. It's a very nice point when x equals 2. And a very nice point here when x equals -1, 2, 3, 4. -4. So, overall, my solutions, again, I have 2 of them here, are when x equals 2 and -4. And again, what that means is if I plug these into the original equation, which was x squared plus 2x minus 8 equals 0, I will get a true statement. We already saw that with 2 right here. If I plug in 2, I do get 0. Let's try it with -4 real quick, just to show it. So again, I want a true statement here. If I plug in -4, I get -4, I square it, plus 2 times -4, minus 8 equals 0. I get positive 16 here, -8 equals 0. That gives me regular 8 minus 8, which indeed gives me 0. Sorry, you can see the last part there. But there we go. So this is a true statement, which is a good thing. That means that -4 is indeed a 0 of my equation here. So the solutions to this quadratic equation right here are 2 and -4. There we go. So that is how we determine the solutions to a quadratic equation by graphing. Graph it, and then we'll set it equal to 0, then graph it, and then find the x-intercepts. That's all we got to do. Alrighty. So, stay tuned for the next video. The next video is going to be super short. It's all about what if I don't have nice x-intercepts. These ones are both whole numbers. These ones are both whole numbers. What if it's not that way? So stay tuned for that next video for Chapter 4, Section 2, and we will continue learning about all of this in class.